in your database. There's specific houses, those would be points. You know, streets would be lines, these long linear features. Land parcels might be adjacent neighboring polygons. The raster model, on the other hand, it takes some area and then breaks it up into a grid of uniformly sized cells. So it's continuous over that area. Each grid, or each cell in that grid, takes on some value. Even if that value is no data, it still exists. So the raster model is typically used to represent data that vary continuously over space. So a very common one would be elevation. Right? The Earth's surface doesn't ever just stop. You know, it might be a cliff and it might continue much further below, but the Earth's surface doesn't stop. So we use a continuous raster model where each cell represents the average elevation of that area. Land use is another commonly used raster, or is commonly represented as a raster, right? Where each cell might be, these might be the, say, industrial areas, this would be water, this might be forest, pasture, and so on. So this is an important concept in GIS. It's one of those fundamental things you have to hold on to as you learn more and more. So just to recap, a vector model is, or I should say, raster data are, anybody? Continuous, right? Raster data are continuous over some area, and it's this grid of uniform cells. So vector data are, they're discrete, right? And they take the form of points, lines, or polygons. Yep. So when it comes to actually using these two models, there's never a clear right or wrong. There's usually a better or worse. Hi, come on in. So let's take a look at a few examples here, just to explore that idea. So these are a few different things, some examples of the way we could look at, for instance, hotels is my first example. Right, so these are just some location of hotels. In the vector model, I'm sorry, the raster model, you're going to build this grid, divide it up into cells. Most of those are going to say, not a hotel. And then a few of those grid cells are going to say, yes, I am a hotel. The vector model is just going to say, here are a few points with some X and Y position that are a hotel. And that's the entire data set. So any thoughts on which makes more sense? I mean, you have a feeling about, is one better than the other?
I think it depends.
Okay.
Like if you're using for land use, it would be better to have a raster image rather than a vector.
Sure. I mean, for hotels specifically, though.
Oh, okay. For hotels, I would go with vectors.
With vector, right? Because in the raster, you have this entire data set, and you're really only interested in a few of those cells. Yeah. But you're storing a file that is mostly not a hotel, right? I think the idea is the same for lines. This example says ski lifts, but it could also be roads, right? So the vector model just takes a few points, connects those, and says, here's where my roads, here's where my ski lifts are. The raster model is going to have mostly cells that say not a road or not a ski lift. But going back to your example, something like land use or a forest, you know, any thoughts on which one's more appropriate there? A raster? And can you elaborate why?
Because it shows you the particular area, how it's spread.
Mm-hmm. Right, so things like aerial or satellite photos are very often analyzed using GIS to determine things like the species or the health of the vegetation and so on. So forest, raster is probably a good way to go. Unless you're only interested in the boundary and you don't really care what's going on in the forest, I just want to say, here's the edges of the forest or that property. Then maybe using a vector model makes more sense. Let's go down to elevation, right? So again, a classic raster data set would be what's called a digital elevation model, a DEM. You can also say sample that raster at a few locations and get these points and then interpolate and develop these contour lines. So, again, different ways of representing the same data. So, any questions about these two models? Another thing to consider might be the scale, at which you're viewing the data. So, for instance, if you're looking at rivers, at the scale of, say, the country as a whole, you're probably just going to have lines. But if you're looking at, say, within an individual city, the river might be very broad and have a significant area associated with it. So you might have to use a polygon. Does that make sense? All right. So now I'd like to talk for a minute about the software you're going to be using. Today, you're going to start using what's called the Arcgis Desktop package. This is actually a set of programs that work together. The ones you'll be using are Arccatalog and Arcmap. And then running behind the scenes in those is something called Arctoolbox. Arccatalog is what you're going to go to for previewing, organizing, managing, and editing your data as far as the naming goes. Arcmap is what you usually go to create maps or actually perform analysis with your data. There's not only a desktop version, Arcgis has expanded in the past decade or so, especially into online browser-based versions that store all your data in the cloud. You don't actually need to install any software. They have mobile versions, so you could use on your smartphone, on a tablet, server versions, just a variety of different options for what you want to use. They also have add-ins for things like Microsoft Excel, so you can turn a spreadsheet directly into a map. All of these different apps are linked through an ArcGIS account, which we can help you set up later if you're interested. This basically gives you access to all the different types of software. So you could say work in the desktop, like on these computers, and send your data to their servers to be stored and then access it on a different computer. And all these different things are linked through that account. Okay, so any questions on what a GIS is? Vector data, raster data? All pretty clear? All right, so let's move into the hands-on activities then. The first thing we're going to do is use Arccatalog to preview data. We're going to see what GIS data consists of. Arccatalog is the program for this. I think its name comes from, here's another tongue-in-cheek reference to the olden days when you had a card catalog in the library and you'd actually have to physically look through something to find data. Anyway, it's sort of like Windows Explorer, right? This is, you move through your files, you open data and take a look at it. And you need to do this to use it for your GIS data, especially for deleting, renaming, copying, and pasting. And I'll show you why that is. So, what you'll want to do is, on each of these computers, if you go to my computer, to the D drive, it's a secondary hard drive, you should have a folder called Introduction to GIS. And I have a lot more things on my D drive. If you don't have it, please raise your hand. And I think I added it to all these computers already, but I might have missed one. So if you open that folder, Introduction to GIS, you should see two other folders. One called Data and one called Handouts. And if you open the Handouts folder, you should see 4 PDF documents. These are, as a reference to you, I'm going to work through these. We're going to work through them together. These are available to you to download later for your own reference, or if you'd like to open it and follow along, you're more than welcome to do that. Okay, so to begin, what we'll want to do is actually open Arc Catalog. So if you go to Start and All Programs, to the ArcGIS folder, and we'll open Arc Catalog 10.4.1. And I should say now, if you have any questions as we go, if you get stuck, please raise your hand and I'll come around and help you get caught up.
You said that's Arcmap.
Arc Catalog is the one we'll want to open. You got it? Okay. So the first thing we need to do with Arc Catalog is tell it where our data live. We need to set up a file path before we can preview our data. So let me remove all mine. And does everybody see the catalog tree here on the left when you open that window? If you don't, raise your hand. What you'll want to do is click this button up at the top. It's right here. It says